All right, today we are going to practice taking notes with section 1.2. And 1.2 is talking about measuring and constructing segments. Remember yesterday we learned that segments is part of a line. A line goes on forever and ever and always and never stops, whereas a segment is only talking about the distance or the length between 2 points. So a segment would be this black part of the entire line. And today we're going to talk about measuring and constructing them. We're actually not going to be constructing them yet, I apologize, but later we will. So example one, the first thing you're going to do in the book is talk about distance and length, and those are words that you guys have used before, but something I would write down is that the answer always needs to be positive. It wouldn't make sense if you said that the mall is negative 2 miles away, right? So these examples are problems that you did in Algebra 1. Number 1 and 2 should be pretty easy for you guys because all you have to do is really count on the number line. However, if I didn't give you the number line, you would have to be either adding or subtracting, right? So if I wanted to know, for example, number 2, find the length of AC. Well, A is at -2 and C was at 3. You're going to have to subtract these two things, and then you're going to get -5. But probably you guys are remembering, well, wait a second, it has to be positive. That's because you need to take the absolute value. And so the answer for number 2 is really going to be +5. Number 3 and 4 are a little bit challenging. I want to see if you guys can figure those out. We'll talk about it tomorrow in class. Example 3. Okay, so we're still talking again about segments. And some important keywords that you need to know for this section is the word between. I want you to write down that the word between does not mean middle. It's hard for me to explain what between means, but I know for sure it does not mean middle. Sometimes in geometry you're going to have to draw your own picture. So for example, for number 5 it says point G is between, there's that word, point F and point H. So that means that F and H are on the same line somewhere. So here's point F, here's point H. You can go ahead and draw these on your notes. There's my straight line, and G is somewhere between. And I'm going to remember that it's not the middle. So I'm not going to put G in the middle. I'm going to put it close to either F or H so that I remember that G does not have to be in the middle. Cool, so now we have our line segment. Then we're going to fill in all the numbers. It says line segment FG is 6 units long. And it says that FH is 11 units long. Well, that's this whole segment right here. And then they want us to find the missing piece, GH. So they want us to figure out how long this segment is. What we can use, some of you guys are like, duh, this is already going to be 5 because 6 plus 5 makes the whole thing 11. It's important that you guys take note, put a star by this postulate. It's called the Segment Addition Postulate. This is just a fancy word for what you just did right here. This basically says that if you know what one piece is, one part of the line segment, like for example that this part is 1, and you know that this part is 4, well then you can add those up together and figure out that the whole thing is 5. Okay, so segment means we're talking about line segments. Addition means we're going to add up the two smaller pieces to make the whole piece. And postulate is a fancy word for something that we can believe to be true. So segment addition postulate is important. We use this for proofs, which we will be doing next chapter. Okay, so number 5 was an easy one. Number 7 is just like number 5. And so you're going to have to draw a picture. The only thing that's different is that there's a little fraction here. Number 6 and, number 8 are similar. Number 6 and number 8 are really the same thing as number 5, but the only difference is that we're throwing in x's at you guys, so you're going to have to use some algebra. So to set this one up, I'm still going to use a segment addition postulate. So let's see, this piece is 17. This smaller piece is 3x minus 5. So I'm going to add those together because it's the segment addition postulate. And I'm going to say, well, if I add up this piece and I add up this piece, that's going to make up the whole line segment NO. So I'm going to say that it equals the 5x plus 2. And now I'm going to have to do my algebra. I want to see if you guys remember how to do your algebra. So go ahead and see if you can try to solve for x. Go ahead and see if you can try to solve for x. If you have x, remind me tomorrow we're going to come back to this problem. I want to see if you can solve for x. And then I want to see if you can figure out, after you know what x is, can you plug it in and tell me what NO is? So can you tell me what the whole line segment NO is? If you can do number 6, go ahead and try to do number 8. If not, we'll do it in class for sure. Okay, the last thing we're going to talk about is midpoints. Midpoints. I'm sure some of you guys can guess, mid means middle, point means point. So midpoint it's a noun. It is the point that's exactly in the middle. So let's say, for example, I have this line segment AC, and I'm going to tell you that B is the midpoint. Well, cool. It kind of looks like it in my picture, right? But to make sure you guys know 100% for sure it's midpoint, we're going to use these things called tick marks. So I would write down tick marks. Tick marks show that two pieces are going to be congruent, or of equal size. So for example, if I went like this, here are my tick marks. Now that picture tells you that AB is going to be absolutely the same size as BC. So that's really important. So midpoint, B would be the point that is in the middle. To bisect is the verb. So it's the thing that's cutting something down the middle. So for example, I could say B bisects line segment AC. So midpoint and bisect mean pretty much the same thing, except midpoint's a noun and bisect is a verb. Segment bisector would be something, a line segment of some sort that is cutting something else in half. So for example, here I have some segment, let's call it AC. And then here I have down here this other line segment, BD. Well, I could say that BD is the segment bisector if I put these tick marks. So that means it's cutting AC in half. Okay, and then the last verb, the last word before we move on to some more problems is congruent. I want you to write down this symbol. We use this so much in geometry, and I want you to write down that congruent means the same size. And we'll talk about why we can't just use an equal sign tomorrow. So we'll put a star. We'll talk about this more tomorrow. Okay, so 9's the last one we're going to do. It says D is the midpoint of EF. So what we're going to do, we don't have a picture. We're going to draw that picture. So we have line segment EF, and it says D is the midpoint. So that means D has to be in the middle. And you can't just draw it like this. This does not tell me that D is in the middle. You have to put those tick marks. Now we're going to fill in what they tell us. So they tell us that ED is 4x plus 6. So this part is 4x plus 6. And they tell us that DF is 7x minus 9. So this part is 7x minus 9. Given just that information, you can find out how long ED is, how long DF is, and how long EF is. And some of you guys are going, well, hello, Miss Broyles, we already know what ED is. ED is 4x plus 6. If you went to the store and bought a shirt for 4x plus $6, I would really, really be interested. Please let me know. Okay, so how we actually figure out how long this is in terms of numbers, we have to set these two things equal to each other because this segment is going to be equal to this segment. So 4x plus 6 is going to equal 7x minus 9. We have x's on two sides of the equal sign. So what we're going to do is we're going to move one of them over. I'm going to move over the 4x because that's what I want to do. If you wanted to move the 7x over, that would be totally fine. So now we have the 6, we have an equal sign, and let's see, 7x minus 4x is 3x, and we still have that negative 9. Okay, we want to get the x by itself. So we have this negative 9, and we have this 6. So I'm going to move over this negative 9. And so now we have that 3x equals 15. And some of you guys can figure it out from here. That means x is going to equal 5. And I'm going to tell you right now that most people are going to stop here. And this is the most common mistake that geometry students make is they're like, yay, I'm done, happy dance. Don't do your happy dance yet. Go back, read the question, because geometry is going to ask you mainly for segment lengths and angle measures and stuff. So that means since I want to find out what ED is, you have to take this x equals 5 and plug it back in. So if x equals 5, 4 times 5 is 20, plus 6, this part is 26. So I can say that ED equals 26. Now, some of you guys are going to go on and plug it into here. Totally fine. But didn't we say that these two segments are equal to each other? So that means DF is also going to equal 26. And then if I wanted to know what the whole segment is, EF, well, all I'd have to do is add these two up. And so you're going to get 52. All right, so we're going to talk about this more in class. You guys rock. Make sure you go back and talk about 2 things that you learned today.